Hello everyone, good evening. So today in our present video we are going to start kinematics, that too motion in 2D plane. So that is nothing but in two-dimensional motion of a particle. We are going to study about it in detail. So as a part of it, in this video we will just have introduction to the motion in 2D plane. So what sort of all key words and all everything basic knowledge you need to learn in order to understand 2D plane, that is motion in 2D plane easily, we will see in this video, and then we will continue with the motion in 2D plane topics in the next video. So let us start with the introduction. See, as we have seen in vectors directly, so whenever you just want to represent any particle position, we will be representing with the help of a position vector. That is a well-known task for us. And say there is a point A, x comma y located in x and y plane, that is two-dimensional, right? So say this is your origin, and now this is the vector, whatever we say, that is nothing but position vector o a bar. So for time being I am just assuming that let o a bar be called as some r bar. So therefore now r bar can be expressed as, straight away we know that x units along x axis. So unit vector representing along x axis is represented by I cap. So therefore xi cap plus y units along y axis. So therefore unit vector representing along y axis is j cap. So therefore xi cap plus y j cap. So this is what r bar, that is nothing but position vector representing point A, that is nothing but a particle started from origin, you can even say, and it ended at a point A, x comma y. So now here this r bar can also be called as some like displacement vector from origin. Okay, so displacement vector from origin. So now you might got it out, sir, displacement vector from origin you said, right? So what if this particle started from a different point and ended at different point? Very good doubt. So let us go into that also now. So see in this picture here, so this is along x-axis and say this is now y-axis, right? As visual we know. So there is a particle which is started at A, say it is located at x1 comma y1, and it is about to reach point B. So say this is x2 comma y2. So therefore the particle started from A and ended at B. So therefore its initial position is A and final position is B. So now let location of A, so can be done by, already we know that the position vectors we know, right? So therefore position of A can be done by OA bar. So let OA bar be some R1 bar, that is equals to x1 I cap plus y1 j cap. Done, we already know this. And also B bar or nothing but position of B can be expressed from the origin straight away with another position vector, say this is O. So therefore OB bar, you can even say this one as R2 bar for time being. So this is x2 I cap plus y2 j cap. So say now the total, the movement from A to B for this particle is being done directly now, whatever we have calculated. So therefore let me say the displacement of this particle from A to B be represented by delta r bar. So say this is displacement. So therefore r2 bar minus r1 bar. So that is directly you can do it like x2 minus x1 of I cap plus y2 minus y1 of j cap. So this is your displacement vector as from A to B, and that too it can be represented by delta r bar is equal to r2 bar minus r1 bar, where this one I would like to represent as our displacement vector, that to a particle moving from point A to point B. Done. So now assume let this journey be done be done in a interval of time, or in a time interval, in a time interval of delta t. Smallest journey I'm just assuming, right? So in a time interval of delta t. So therefore we can even say now velocity gained by this particle, or velocity of this particle also is going to be a smallest one only for time being, we can assume in that way. So therefore whatever I would like to say is velocity of the particle here in this case can be written as, so velocity of particle can be written directly as v bar. So that is nothing but displacement covered. What is the displacement covered? Delta r bar, and time taken t. What is that? Delta t. So this is done straight away for us. So therefore v bar is equal to delta r bar by delta t. So already we know now one more point. If the time interval approached, or if the time interval considered is very small, so if the time interval whatever we considered is very small, that is nothing but if it tends to 0, if the time interval is tending to 0, then we can have a displacement covered also will be a smallest thing. So therefore v bar now can be having a limiting value, which can be written as like this. So d by dt of r bar. So this one we have learned in differentiation concept only. Rate of change of displacement is called as velocity, and what we have this r bar now, whatever this one here, see smallest change or whatever we considered. So let me say this is v bar. So if you are having a confusion with this, so you can even this remove this delta over here. So directly you can say r bar is equal to r2 bar minus r1 bar. That is straight away you can say x1 i2 x1 I cap plus y1 j cap, or x2 I cap plus y2 j cap, however you just want to write, you can even say. And also we expressed, see this is here starting only we have written r bar is equal to xi cap plus yj cap. That also you can substitute here, no worries at all. So d by dt of x I cap plus y j cap. So now using some rule we can just separate it, and already we know, right, what is this? Rate of change of displacement is equals to velocity. Already we confirmed it. So now what is x here? Displacement along x-axis. So rate of change of displacement along x-axis will give you velocity of the particle along x-axis. Velocity of the particle along x-axis, that is nothing but I cap, plus rate of change of displacement along y-axis, that is y. So therefore it also can be given as vy j cap. So this is overall velocity vector, that is representing the velocity of a particle moving in a two-dimensional plane. So vx I cap plus vy j cap. And also we know, and listen here, this vx and vy are independent of each other. Vx and vy are independent of each other. And next, so on further, if you just consider the acceleration also, we know, right? What do you mean by acceleration? Straight away in applications of differentiation we learned. So acceleration is equal to rate of change of velocity. By the definition itself we know. So just substitute. So d by dt of vx I cap plus vy j cap. So now we will be getting directly a bar is equals to rate of change of velocity along x-axis, that is nothing but acceleration along x-axis, and rate of change of velocity along y-axis, acceleration along y-axis. So a bar is equal to ax I cap plus ay j cap. So these are all nothing but your expression for velocity as well as acceleration representing in a vector form, that is nothing but a particle's movement in a two-dimensional plane. So as we already know that there are equations of motion for horizontal motion as well as vertical motion of a particle. So now let us see the equations of motion for a particle in two-dimension plane. So equations of motion for a particle in two-dimensional plane. For a particle moving in 2D plane, or in plane you can say 2D is nothing but plane only, right? Yeah. So what is the first basic equation we are having? Equation of motion, v is equals to u plus at. So now where v is final velocity, u is initial velocity, a is acceleration, and t is time taken, we already know. So now along x-axis, you would like to write now this one as along x-axis. So straight away you can say vx, velocity along, final velocity along x-axis, is equal to initial velocity along x-axis plus acceleration along x-axis into time taken. Similarly, along y-axis, you can also even say this one as directly. Straight away we are giving its components like vy is equals to uy plus ay into t. So this is your velocity. So first equation of motion. The second equation of motion we are having displacement covered, right? So s is equal to ut plus half a t square. And now along x-axis, see, already starting only we learned that the displacement covered by the particle along x-axis is x. So therefore x is equals to uxt plus half ax t square. And similarly along y-axis also we learned that the displacement of the particle along y-axis is given by y. So that is equals to uyt plus half ay t square. Here ax, ay, ux, uy are all nothing but components of acceleration and velocity along x-axis as well as y-axis, as we are considering it is a motion in a plane. And third one, v square minus u square is equals to 2as. So therefore as usual along x-axis now. So along x-axis all x components will be considering. So therefore vx square minus ux square is equals to 2 into ax into displacement along x-axis is x. And similarly along y-axis, if you would like to say this one as like this, so it will be vy square minus uy square is equals to 2 into ay into displacement along y-axis is y. So these are your three equations of motion described for a particle moving in a 2D, that is nothing but moving in a plane straight away. So now already we know that velocity expressions we know. So on integrating velocity, what we will get is straight away we'll be getting the position, right? That is nothing but displacement. So let us take that one and do the fourth one over here. So say that the velocity of the particle is given by v equals to u plus at. V is equals to u plus at, right? So now let us see here this one. So integrate with respect to time t. Integrate with respect to time t. So now what you are going to get, integral v dt is equals to integral u dt plus integral a t dt, right? So what is this integral v dt? Already we know this one is change in displacement we are going to get straight away over here. So therefore that is change in displacement. I would like to write like this one as, so displacement I am representing with s. So change in displacement, that is displacement final minus displacement initial, is equals to u into this one gets to be integral 1 dt, that is ut, plus this one is a will be outside, so integral t dt t square by 2, so this is a t square by 2. So therefore displacement covered final is equals to initial displacement plus ut plus half a t square. So now if you just observe or apply this category for along x-axis as well as along y-axis, so straight away we will be doing this one. So along x-axis you will get displacement, final displacement is equals to initial displacement covered plus ut plus half a t square. So what do you mean by this final displacement and initial displacements directly? So initial is nothing but at a time t equals to 0. At a time t equals to 0. Then what do you mean by final then? At a time t is equals to t. So similarly along y-axis. Similarly along y-axis is also the same thing. So y final displacement along final, y-axis final is equals to initial displacement along y-axis plus, similarly see these all x terms, right, coordinates. So therefore you would like to write this one as uxt plus half axt square. Similarly here uyt plus half ayt square. So like this we can just have an understanding about all these categories, which can be considered as an easiest task for us to understand the motion of a particle in a 2D, that is nothing but along a plane. So with an example, if we would like to see this whole thing, it will be very easy, I hope so. So that example I will be explaining in the next video to you, so it will be a clear cut point to you. So thank you very much. Hope you understood. Any doubts, please post in the comment section.